Okay. Good afternoon, everyone. I'm Xiaoxi Li from Renmin University of China. I'm the proxy presenter for my peer's work, the generative retrieval via term site generation. This presentation is divided into 5 sections. First, let's start with the background. For document retrieval task, current works mainly including the sparse and dense retrieval method. The sparse retrieval represents document and queries with sparse vectors in the vocabulary space, which is the back-of-word representation. And the dense retrieval represents the documents and queries with dense vectors in the latent space. Yeah, and however, both of them rely on standalone indexes to conduct the retrieval task, which cannot be optimized together with the retrieval model. And then the generative retrieval model. This method represents a document with a short and unique identifier. For example, the title of a document, and it is namely doc ID. It employs a generative model to remember all the doc IDs inside their parameters. When a query comes, the model directly generates the relevant document's doc ID through constrained beam search. This method parameterizes the entire retrieval pipeline, and hence the retrieval task can be optimized end-to-end. And then the motivation of this work. Well, the doc ID is one of the most decisive factors that influence the performance of generative retrieval methods. And each document is identified by a natural language sequence, such as the title. The relevant document can only be retrieved when the entire sequence is precisely generated. However, this causes a false pruning problem of the sequential doc ID. That is, the decoding is a step-by-step process where a single intermediate area will permanently prune out the relevant doc ID. And the model is likely to make such mistakes because it is short-sighted. It cannot precisely suffix tokens. We can see from the example that when user input a query, asking what is the sodium level in the wet bread, and supposing that we have 3 documents in the corpus, and this 3 sequence is the doc ID of the corresponding document. And we can see from the model's decoding process that in this decoding token, the model chooses the token sodium rather than the token calorie based on the generation probability, because based on the query, the token sodium have higher generation probability than the token calorie. However, we can see from the second sequence that it is talking about egg rather than the users asking about bread. Therefore, the second sequence is not relevant at all. The first correct sequence is pruned out. That is the false pruning problem. And in this work, we propose a systematic solution with term site doc ID. In this method, each document is identified by a set of key terms within it, where any permutation of the term site leads to the very document. During the decoding process, the relevant doc ID will not be pruned as long as the decoded terms belongs to it. The model has a broader perspective. It can perceive all terms in the doc ID and make more reliable choice. And finally, the model can explore the optimal permutation on its own, according to the input query to generate the relevant term site. And also, back to the example. We use the term site doc ID to represent each document. Each term is selected based on the selection model, and we get the key terms to represent each document. And at each decoding process, the model chooses the most appropriate token in the token space. First, in the first decoding process, the model chooses the token from all the valid tokens in the term site .id space. And in the following step, the term space will gradually narrows down. And finally, we get the sequence of the correct term site, which is naturally resolve the problem of false pruning problem. And there are three critical challenges for the effective utilization of term site.id. First, how to select the terms. And we devise a term selection strategy, learn the term selection strategy to find important and discriminative terms. And second, how to generate the term site using the autoregressive model. We propose a permutation invariant decoding algorithm to enable efficient generation of the term site. And third, how to optimize the generative model. We leverage an iterative optimization process to incentivize the model to generate the relevant term site in its favorable permutation. And then the method, we will discuss each method in detail. First, learn the term selection. We select the terms that not only present the document, but also distinguish the document from others. Following sparse retrieval methods like unicoil, we use a BERT to learn the term weights through contrastive learning. And this loss function encourages the model to increase the term weights that facilitate accurate matching, while decreases the one that don't. In our experiments, we found that 12 terms are enough for distinguishing 100K documents. And second, the permutation invariant decoding. In our naive approach, we need to maintain all the permutations of the term site.id, but that results in n factorial sequences for each document. It is intractable. And in this work, we propose an alternative method to achieve the same goal with three critical properties. The first is valid. The generated term site exists in the corpus. And second is optimal. The model is allowed to explore the favorable permutation of the term site on its own according to the input query. And second is efficient. The ON space complexity and competitive decoding speed thanks to the inverted index-based implementation. And on the right table is the detail of our algorithm. You can see this GitHub link for the detailed implementations. And third, the iterative optimization. The generative model is trained by the seek-to-seek laws. However, there are n factorial possible target sequences. We train the model to follow the most probable one according to its own estimation. At TTH iteration, let the model's latest snapshot theta t-1 to permute out target term site according to the training query. This is the optimal permutation that is most likely to be generated. Train theta t-1 with this optimal permutation as target sequence, and then update snapshot theta t. The terms are ordered descendingly by the term weights at the first iteration. The model coverage after 2 iterations. And that's the method. For the experiment, we use NQ320K and MS Marco 300K as our datasets. For implementations, we use T5 base as our backbone model, and we select 12 terms for the 2 datasets. And we use 10 synthetic queries generated by doc T5 for each document as training data, and we cite the beam size as 100. Then the experiment result. we evaluate our model's retrieval performance on these two data sets. We can see from the result that the TSGen outperforms existing generative retrieval method in both recall and MLR. It can retrieve documents that were falsely pruned, and it can rank the relevant documents higher using the optimal permutation of the term set. And then we evaluate the memorization and the generalization capability on seen and unseen documents respectively. In order to study the memorization and generalization capability of our model, we split the corpus into two halves, where the model is only trained with queries on the seen half. Notice that the prefix tree for the baseline methods are pre-built over the entire corpus. Otherwise, the clustering-based approach like NCI would have zero accuracy on unseen half. We can see from the results that TSGen achieves substantial improvements over existing methods on the unseen half. And then we conduct experiments about case study and the evaluation of efficiency and ablation studies. We can get the following conclusion that the term site doc ID is the main source of effectiveness, and the decoding speed of our model is competitive against the conventional tree-based approaches. And TSGen retains its advantage without synthetic queries, and our model benefits from larger backbone models. Yeah, that's the experimental result. And finally, to get a conclusion, we propose TSGen, a novel generative retrieval framework that identifies each document with a set of key terms to mitigate the false pruning problem of sequential doc IDs. And we devise tailored techniques for our model, including the learned term selection, the permutation event decoding algorithm, and the iterative optimization procedure. Finally, we conduct extensive experiments on popular generative retrieval benchmarks. The results validate the effectiveness, generalizability, scalability, and the efficiency of our model. That's all for my introduction. Thanks for listening.